Prosthetics are artificial devices that replace missing body parts of amputees to help restore the original functionality. 82% of amputations are caused by diabetes and vascular diseases, 16% are due to trauma, and 2% are due to cancer. In the past 10 years, there have been huge advancements in artificial limb technology, but users have highlighted some serious issues. It's the loss of sensory feedback. The issues with this solution are due to copper wires being used to stimulate the nerves. Firstly, the copper wires often carry too much power and end up damaging the nerves. The second problem is that the electrical signals tend to stimulate too many nerves, resulting in incorrect sensory feedback being transmitted to the brain due to the lack of precision. And finally, there is often interference between electrodes. Electrical stimulation impulses interfere with signals that other electrodes receive. As a result, the actual message never reaches the brain. So, because of these problems, it's clear that the needs of the amputee victims are not being met by the current solution. Prosthetic limbs should provide fast, uninterfered and precise sensory feedback with a solution that doesn't cause permanent damage to the user's nerves. We believe that we have found this solution. This solution takes an entirely different approach. Instead of using copper wires to stimulate the nerves, optical fibers are used instead to stimulate the nerves using pulses of light. Optical interfaces are devices used to wrap around the nerves and mount the fiber optics onto the nerves. The light passes back and forth through the fiber using reflectors that transform light energy into an electrical current. More specifically, light stimulation causes changes in the neuron's temperature, which cause the ion channels within the neurons to change state, creating a measurable current. So, the current is transferred to the spinal cord and finally to the brain, which in turn responds to the electrical pulse by responding with an action that the body executes. The reason why fiber optic neuroprosthetics are such a promising solution is because they address these key issues. Firstly, damage to the nerves is avoided. No damage is caused to the body by the light pulses. Glass fibers can be made much thinner compared to metal electrodes before they reach their physical limits. This reduces the inflammation of surrounding tissue when the prosthetic is attached to the body. Secondly, inaccurate stimulation is avoided. The precision of light pulses provides much more selective activation. Light can be guided through reflectors to excite just a single spot on a single nerve. As the pressure becomes higher, more and more nerves can be excited independently. And finally, there is no interference between the optical fibers. Signals from different fibers can easily be recorded independently, allowing them to be combined to measure varying pressures. So, this can occur without affecting the signals of other fibers targeting the same nerve before it reaches it. Beyond the technical suitability of this solution, there are also numerous social and environmental benefits also. Restoring sensory feedback to amputee victims allows them to restore normal working and social lives, thus helping them to relieve the psychological burden that inevitably comes with limb loss. Furthermore, through sensory feedback, users will be able to prevent unfortunate accidents that inevitably occur when one has no sense of touch, thus reducing the healthcare costs that these individuals will incur, therefore improving their quality of life.
And finally, due to the latest developments in 3D printing technology, cost-effective prosthetics can be manufactured to be bespoke to the user whilst using sustainable materials such as PLA, ABS and PVA. These materials can be recycled and attained much easier than the metals used in the current electroprosthetic solutions, and so result in a more environmentally friendly solution.